Okay, I hope I'm audible to all the students who are attending this lecture of Introductory Microeconomics. We continue with our lectures on consumer theory, which is a very important topic within the microeconomics course. Okay, formally, this is chapter 21 of the book which I am following for my lectures on introductory microeconomics. This is Gregory and Mankiw. Okay, so I'm following this book for my lectures on introductory microeconomics course. Okay, and we are looking at chapter 21, which is consumer theory. Okay, now in the previous lecture of consumer theory, we were discussing about the affordability of the consumer, which is captured by budget lines. Okay, we had done the equation of budget constraint, equation of budget line. We had drawn the budget line. We had a good discussion on the horizontal intercepts, the vertical intercepts, and the slope of the budget line. Then we had also talked about the shifts caused by income and prices, the impact of income and prices on the budget line. Okay, now in this particular lecture, we intend to look at consumer preferences. In this particular lecture, we intend to look at consumer preferences, and consumer preferences are captured by indifference curves. I expect students to know the basic theory of indifference curves from high school economics. Okay, so when we talk about consumer preferences, graphically, they are captured by indifference curves. So what is an indifference curve? Okay, so let's talk about what is meant by indifference curve. So an indifference curve is a curve which shows all combinations of two commodities which give equal satisfaction to the consumer. Okay, so when we talk about indifference curve, it is drawn in the 2D space. Okay, we have two axes, x and the y axis, and it is showing us it is a locus of all points which shows combinations of two commodities which give equal satisfaction to the consumer. Okay, so if I quickly draw the diagram, let's draw the diagram for the indifference curve. So this is my origin. Then we have good X or commodity X on the horizontal axis, and we have commodity Y on the vertical axis. Okay, so one particular indifference curve is something you can see on your screen, IC0. Okay, why is indifference curve downward sloping? Why is it convex to the origin? I will be discussing in a few minutes. But right now, this is one indifference curve which you can see on your screen. If I take 3 points on this indifference curve A, B, and C, so point A represents one combination. It's like a vector in 2 dimension, x1 comma y1. Point B represents another vector in 2 dimension, commodity vector x2 y2. Point C represents another vector x3 y3. You can call them as vectors in mathematical terms. In microeconomics terms, you can call them as bundles. Okay, so basically this is my x1, this is y1. Similarly, point B denotes x2, on the x-axis and y2 on the y-axis, and similarly we have point C, which represents the combination x3 comma y3. Now, since all these three bundles lie on the same indifference curve, they give equal satisfaction to the consumer. So I can say clearly, since bundles A, B, and C lie on the indifference curve IC0, they give equal satisfaction to the consumer. They give equal satisfaction to the consumer. Now, whether the consumer can afford them or not is not the question right now in this lecture. Remember, guys, affordability was the previous lecture. In this lecture, we are not talking about affordability. Whether the consumer can afford to buy bundle A or bundle B or bundle C, we don't know. What we know is that the consumer equally prefers the three bundles. Whether you give him bundle A, which corresponds to x1, y1, or you give him bundle B, which corresponds to x2, y2, or you give him bundle C, which corresponds to x3, y3, the consumer will be equally happy. So I can say that the consumer is indifferent between the three bundles. So x1 comma y1, which is represented by bundle A, x2 comma y2 represented by bundle B, and x3 y3 represented by bundle C. This is the sign of indifference. The consumer is indifferent between the three bundles. Okay, so I hope students have understood the basic definition of indifference curve, the diagram. Okay, and this was one particular indifference curve. Okay, what is meant by indifference map? So let us see what is meant by indifference map. So indifference map is a family of indifference curves. And indifference map is a family of indifference curves. Okay, so if I draw the diagram for this, so if I draw the indifference curves at different levels, having the same slope, it is going to give me the indifference map. So this is one indifference curve, guys, IC0. I can draw many indifference curves. IC1, IC2, IC3, and so on. So we are heading towards the northeast direction. And I can keep on making indifference curves in the two-dimension space. So this is my indifference map. Now, important point to understand is all these indifference curves have the same behavior, but they are at different levels. When I talk about behavior of the indifference curve is captured by the slope of the indifference curve. So slope of the indifference curve is called the marginal rate of substitution. Slope of the indifference curve is called the marginal rate of substitution, which is, in short form, we write it as MRS, which measures the rate, at which the consumer is willing to trade one good for another. At which the consumer is willing to trade one good for another. Okay, so when we talk about marginal rate of substitution, it is also called the slope of the indifference curve. and it is going to measure the rate at which the consumer is willing to substitute one good for another. Okay, now important point to understand here is that MRS itself is a variable. So MRS itself is a variable. It is not a constant. You can see the slope is a constant if your line is linear. Now, if you all can recall the slope of the budget line, which was the ratio of the market prices, that was constant because the prices were assumed to be fixed. But if you look at the indifference curve, it is convex. It is not a straight line. So the slope of the indifference curve is not a constant. The slope of the indifference curve is a variable. So it depends on, MRS itself is a variable. It depends upon the amount of good being consumed by the consumer. It depends on the amount of good being consumed by the consumer. So what we need to understand, that slope of the budget line is a constant. Hence, budget line was downward sloping and linear, but slope of the indifference curve, which is marginal rate of substitution, is not a constant. It is a variable. As we move from left to right along the indifference curve, MRS will keep on changing. And MRS simply measures the rate at which consumer is willing to trade one good for another, is willing to consume one good for another. Okay, so I hope students have understood this. Now, let us look at the properties of indifference curves. Now, properties will explain in a better way why are indifference curves downward sloping, why are they convex to the origin. Okay, so let's look at all these properties one by one. So our next heading now is properties of indifference curves. Properties of indifference curves. Okay, so guys, let's look at the first property on our screen. Property 1. Property 1. Indifference curves are downward sloping. Indifference curves are downward sloping from left to right. Indifference curves are downward sloping from left to right. Okay, so guys, we need to understand why are indifference curves downward sloping. Now, to understand that, let me draw a diagram for all of you. And let's understand through a diagram as to why they should be downward sloping. So we have good X measured on the horizontal axis and good Y measured on the vertical axis. Now look at this, guys. I take one combination. Suppose this combination is X1, comma Y1. And let me denote this point as point A. Okay. Now, all students from high school economics should be familiar with monotonic preferences. Recall the concept of monotonic preferences. Monotonic preferences simply means more is preferred to less. Monotonic preferences simply means that more is preferred to less. So I can write preferences are said to be monotonic. Preferences are said to be monotonic if given any two consumption bundles. If given any two consumption bundles, the consumer the consumer prefers that bundle. The consumer prefers that bundle which consists of more of one of the goods, but no less of another. So guys, we have done this concept of monotonic preferences in high school economics as well. We say that consumer preferences are said to be monotonic. If I take any two consumption bundles, the consumer will prefer that consumption bundle which consists of strictly more of one of the goods but no less of another. For example, suppose I take two consumption bundles 2,2 and 2,3. Then the consumer will strictly prefer 2,3 over 2,2. Why? Because it consists of more of one of the goods but no less of another. You can see 2 is the same here, but 3 is more than 2. So consumer prefers 2,3 over 2,2. Okay. Similarly, another example would be, suppose we have 2,2 and we have 3,4. You can clearly see consumer prefers again 3,4 over 2,2 because it strictly consists of more of both the goods, and more is always preferred to less. But let's look at the third case, guys. Suppose I have 2,3 and I have 3,2. Can we now say which bundle is preferred by the consumer? If the consumer has normal preferences, simple preferences, then which bundle is preferred? Now we can't use monotonic preferences here, because if you compare good X is more here, but good Y is more here. So in the third case, we cannot have monotonic preferences working. So I hope students have understood this. I hope students have understood the concept of monotonic preferences. Preferences are said to be monotonic if given any two consumption bundles. The consumer prefers that bundle which consists of strictly more of one of the goods but no less of another. So you can clearly see in the third case, it consists of more of good 1 but less of good 2. This bundle consists of more of good 1 but less of good 2. So we cannot have any preference between these two bundles, any monotonic preference between these two bundles. So guys, how can we use monotonic preferences to explain why indifference curves are downward slope? So look at this now. Suppose from point A, I move to point B. In the picture, you can see in the picture, suppose I move from point A to point B. Now at point B, I have more of one of the goods, but no less of other. At point B, you can see my coordinates of point A are x1, y1. My coordinates of point B are x2, y1. So you can clearly see if I apply the concept of monotonic preferences in this diagram, bundle B consists of more of good X but no less of good Y. So clearly in the picture, bundle B is monotonically preferred over bundle A. It means the consumer will prefer bundle B over bundle A. Similarly, guys, if I take a bundle somewhere here, if I take a bundle somewhere on the top, suppose for example, I erase this for simplicity and I take a bundle somewhere here. Suppose this is bundle C. Now, if you look at bundle C, suppose this is Y2, coordinates of A are, what are the coordinates of A? Coordinates of A are, so I can write it here, coordinates of A are x1, y1. Coordinates of C are x1 comma y2. Again, guys, if you apply the concept of monotonic preferences here, you can clearly see that bundle C is preferred over bundle A, because C consists of more of good Y but no less of good X. So now we are talking about indifference. Indifference means we need to find a bundle which is indifferent to bundle A. So let me erase this, we don't need it now. We need to find a bundle. Suppose we are at A, I need to find a bundle which gives me equal happiness as bundle A. Now, when will that equal happiness come? That equal happiness will come only when I increase my good X, I reduce my good Y. Because if I increase my good X, but if I do not reduce my good Y, I will come to B, and B is preferred over A. But on the indifference curve, the consumer should get equal satisfaction. That means if I am increasing my X to get the same satisfaction, I will have to reduce Y. That means I will come somewhere here. You can see, let me call this as point C. So at this point C, you can see that good X is more, but good Y is less, which makes the consumer indifferent. So if I join points A and C, what do I learn? I learn that my indifference curve is downward sloping. So guys, you should be able to argue it out logically. Microeconomics and especially consumer theory is all about logic. The big paragraphs, you can look at my lecture notes. The lecture notes will be shared with all the students. The idea for making this lecture video is to make you understand the concept logically. And logic simply says that if you apply the concept of monotonic preferences, which simply says that more is preferred to less, if I increase my good X, but if I do not reduce my good Y, I will move from A to B, and B will be preferred over A by the assumption of monotonic preferences. But we want to be indifferent because we want to be on the indifference curve. To be on the indifference curve, if I am increasing one good, I will have to sacrifice the other good to be on the same level of satisfaction. So guys, I can write just one line and this line will sum up our property 1. So we can say that indifference curves have to be downward sloping, or I can say that indifference curves are downward sloping. This means that if the consumer prefers to buy more of good X, if the consumer prefers to buy more of good X, the consumer will have to give up some amount of good Y. The consumer will have to give up some amount of good Y to be on the same level of satisfaction. To be on the same level of satisfaction. That is why our indifference curves have to be downward sloping. Because if you prefer to buy more of good X, and if you do not reduce your good Y, you will get more satisfaction. But you don't want more satisfaction, you want same satisfaction. That is something you get only when you prefer to buy more of one good, you give up some consumption of the other good as well. So I hope students have understood this property. Let's look at property 2, guys. Property 2. Property 2 simply says that indifference curves are convex to the origin. Indifference curves are convex to the origin. Or another way of saying it is they are bowed inwards. They are bowed inwards. Now let us look at this property, guys. Why are indifference curves convex to the origin? So when I draw a diagram, so let's take a interesting example. So sometimes we are in a dilemma, should we have ice creams or should we have chocolates? Okay, so as children, suppose we have two commodities, ice cream and chocolates. I'm taking this example just for fun and just to make it more realistic. Okay, so suppose there are two commodities, ice creams and chocolates. Now suppose I have a lot of chocolates with me, but I have very few ice creams. So guys, I am at point A. I have a lot of chocolates, but I have very less ice creams. Now, if someone gives me more ice creams, or if someone says to have more ice creams, initially I will be willing to give up a lot of chocolates for that. So see, my combination was this. Now, since since I have very less ice creams, for every additional ice cream, I will be willing to give up a lot of chocolate initially. So just for this tiny bit of ice cream, I will be willing to give up a lot of chocolates. Why? Because chocolates are available to me in abundance. I have a lot of them. And guys, psychologically, when you have some commodity in abundance, you don't care about that. You start caring about it only when you start losing it. Understand this, guys. When you have something in abundance with you, you don't give too much importance to that. But once you start losing that commodity, it suddenly starts becoming more important to you. That means for tiny bit of ice creams, I would be willing to give up a lot of chocolates. So I can draw even a better case. It's like this. For a tiny bit of ice creams, I will be willing to give up a lot of chocolates. But if I further, suppose if I further buy ice cream, now I will be willing to give up slightly less. Now I will be willing to give up less. Why? Because when I am losing chocolates, their importance are growing. When I further buy one more ice cream, I will be now willing to give up even less chocolates than before. I buy further ice cream, I will be willing to give up very less amount of chocolates. So if I join all these points A, B, C, D and E, you can see I am getting a convex figure. You can see I am getting a convex figure. Okay, so I hope students have understood this logically. Logically, it means as you keep on consuming more of one good, you are lesser and lesser willing to sacrifice the other good. Or I can write it like this. As the consumer prefers to buy, more ice creams, she is lesser and lesser willing. She is lesser and lesser willing to give up chocolates. Every time you prefer to buy one more ice cream, you will be willing to give up lesser and lesser chocolates because chocolates are growing more important for you now because you are losing them. When you start losing something, it starts becoming more important for you. Okay, so that is why you can see they are convex. It's coming out as a board inward shape. Now guys, this was logic, but as students of economics, you should be able to argue it out mathematically also. Now mathematically, why is indifference curve convex to the origin? So indifference curves are convex to the origin. They are convex to the origin because of diminishing marginal rate of substitution. Because of diminishing marginal rate of substitution. What is marginal rate of substitution? It is nothing but the slope of the indifference curve. It is nothing but the slope of the indifference curve. So our indifference curves are convex because of diminishing marginal rate of substitution. Okay, now if I argue it out with all of you mathematically, what does it mean mathematically? Okay, so let's look at it mathematically as to what it means. So what is meant by convexity? Now MRS is nothing but the slope of the indifference curve. What is the slope of the indifference curve, guys? So when I say the slope of the indifference curve, it's nothing but dy by dx mathematically. In mathematical terms, when we talk about slope, it means nothing but dy by dx with a minus sign. Why? Because indifference curves are downward sloping. So MRS is nothing but minus of dy by dx. Now, when I say that they are convex to the origin, it means what? Convex to the origin means that if you work out d square y by dx square, it is going to be strictly greater than 0. This is the condition for strict convexity. This is the condition for strict convexity. Indifference curves will be strictly convex if d square y by dx square is strictly greater than 0. Okay, in high school mathematics also, when we say that, recall guys from high school mathematics, when I say that y is a function of x, when is this function said to be concave and convex? If d square y by dx square is greater than 0, we say that the function is strictly convex to the origin. We say that the function is strictly convex to the origin. And when, if my d square y by dx square is less than 0, we say that the function is strictly concave to the origin. This is something which we have learned in high school maths, as well as students will be learning this in my mathematical methods for economics course. So clearly in this case, you can see that if you work out the double derivative d square y by dx square, you will observe it is strictly greater than 0. Hence your indifference curves are convex. So students should be able to understand this both logically, diagrammatically, and mathematically. Diagrammatically, you can clearly see the picture. Logically also, you can clearly argue it out that as the consumer keeps on consuming more and more of one good, the consumer would be lesser and lesser willing to sacrifice the other good, or lesser and lesser willing to give up the other good. Because when you start losing something, it becomes more important for you. Basic psychology. Okay, so and if you argue it out mathematically, why are ICs convex to the origin? Because of law of diminishing marginal rate of substitution. Okay, that means MRS is nothing but minus dy by dx. Diminishing MRS means what? Diminishing MRS means, guys, if you further differentiate it, So I can make it more clear to all students. If you further differentiate MRS with respect to X, so mathematically I can further go forward. I can say if I differentiate my MRS with respect to X, it is less than 0. This implies if I differentiate d by dx of MRS is what? Minus dy by dx. This is nothing but minus d square y by dx square. This is less than 0, or I can say that d square y by dx square is greater than 0. Okay, it's the same thing. Whether I say that d square y by dx square is greater than 0, or I can say that minus of d square y by dx square is less than 0. Both mean the same thing. But when I say that there is diminishing MRS means that dMRS by dx is less than 0. MRS is minus dy by dx, so minus d square y by dx square is less than 0, which brings us back to the condition that d square y by dx square is greater than 0. So I hope students have understood property 2 and have no doubts in this property. Okay, let's look at property 3, guys. Let's look at property 3. So property 3 says higher indifference curves are preferred to the lower indifference curves. Higher indifference curves are preferred to lower indifference curves. Again, a diagrammatic representation would help to explain this property. So if I have good X on the horizontal axis and good Y on the vertical axis, let me take a point. Suppose this is point A, and point A corresponds to X1 amount of good X and Y1 amount of good Y. And suppose I have an indifference curve passing through point A. Suppose this is my IC0, initial indifference curve. Now guys, suppose I take this point. Suppose this is point B. Now you can clearly see point B is monotonically preferred. It is monotonically preferred over point A because point B consists of more of good X but no less of good Y. Similarly, you can take another point. Suppose I take point C. So since point B consists of more of good X but no less of good Y, I can say that point B lies on a higher indifference curve. Point B lies on a higher indifference curve. Similarly, guys, if I look at point C, suppose let's come back to point A. From point A, suppose I go to point C. Now you can see again point C is monotonically preferred over point A. Why? Because point C consists of more of good Y but no less of good X. That means point C should lie on a higher indifference curve. Point C should lie on a higher indifference curve as compared to point A. Okay, so I hope students have understood that higher indifference curves will always be preferred by the consumer to lower indifference curves. What is the reason behind this? Okay, the reason behind this is monotonic preferences. Okay, so higher, I can write higher indifference curves are preferred to lower indifference curves because of the assumption of monotonic preferences. because of the assumption of monotonic preferences. Monotonic preferences simply means what, guys? We have just done it a few minutes back. It simply means that more is preferred to less. And in the diagram, you can clearly see that bundle B consists of more of good X as compared to bundle A. Bundle C consists of more of good Y as compared to bundle A. I can take any other bundle. Suppose I talk about bundle D. Now, if you compare bundle D with bundle D consists of more of both the goods as compared to bundle. So bundle D lies on even on a higher indifference curve. So bundle D lies even on a higher indifference curve IC3. Because if you compare bundle D with bundle A, it consists of more of good X also, more of good Y also. So I can say bundle D is also monotonically preferred over bundle A. So higher ICs will represent higher level of satisfaction and they will be preferred over the lower indifference curves because we assume that consumers have monotonic preferences. They prefer always more over less. More combination of two goods gives the consumer more satisfaction. So hoping students have understood property 3. And guys, then we have the next property, property 4. So let's look at property 4. So property 4 simply says that two indifference curves can never intersect each other. Two indifference curves can never intersect each other. Okay, so let's look at this property as well. Okay, so let us make the two indifference curves intersect and then let's see whether logically we are correct or not. So suppose I draw a diagram where the two indifference curves are intersecting each other. So suppose this is good X, this is good Y, okay. And suppose this is my one indifference curve, guys. This is IC0, okay. This is my indifference curve IC0. And then we have another indifference curve, which is IC1. Suppose I take points on the indifference curve. So suppose, guys, this is, I can take it as point A here. This is point A. This is point B. And suppose this is point C. Okay. So let's look at the explanation. Okay. Suppose IC0 and IC1 intersect at point B. Suppose both these indifference curves intersect at point B. Now, on the indifference curve IC0, the consumer is indifferent between A and B. You can clearly see that the consumer is indifferent between the bundle A and B. You can clearly see, guys, bundle A and B both lie on IC0. That means the consumer gets equal satisfaction from both A and B. Now, on indifference curve IC1, you can clearly see that consumer is indifferent. Consumer is indifferent between bundles B and C. You can clearly see, guys, bundles B and C lie on the same indifference curve IC1. So consumer should be indifferent between bundles B and C. So this is statement 1, this is statement 2. Now from 1 and 2, what do we learn? From 1 and 2, if the consumer is indifferent between A and B, and if the consumer is indifferent between bundles B and C, from 1 and 2 by transitivity, students who have attended my lectures in mathematical methods for economics, we have had lectures on relations and functions. And in our lectures on relations, we had discussed the concept of reflexivity, symmetry, and transitivity. We have done these lectures in our course Mathematical Methods for Economics. Okay, so by transitivity, the consumer should be indifferent between bundles A and C. Okay, important point to understand here is, if the consumer is indifferent between A and B, and if the consumer is indifferent between B and C, by transitivity, the consumer should be indifferent between bundles A and C. But clearly in the above figure, if you look at the figure, guys, but clearly in the above diagram, the consumer prefers bundle C over bundle A. Why? Because bundle C consists of more of both the goods. Bundle C consists of more of both the goods compared to bundle A. You can clearly see, guys, bundle A consists of this much amount of good X and this much amount of good Y. And if you look at bundle C, it consists of more of good X also. It consists of more of good Y also. So therefore, we have arrived at a contradiction. We can clearly see a contradiction coming in our argument, because if you look at transitivity, if the consumer is indifferent between A and B and C, then by transitivity, the consumer should be indifferent between A and C also. That means A and C should lie on the same indifference curve, but in the diagram, you can see A and C are not lying on the same indifference curve. In fact, consumer prefers bundle C over bundle A because bundle C consists of more of both the goods as compared to bundle A. That means we have arrived at a contradiction. So that means two indifference curves can never intersect each other. So because I can write, because if they intersect, then they violate the law of transitivity. If they intersect, they violate the law of transitivity. So guys, two indifference curves can never ever intersect each other. So I hope students have understood this. Okay, and then you can clearly see the last property we do, property 5, and then we stop in this lecture. Property 5, average bundles are preferred over the extreme bundles. Average bundles are preferred over the extreme bundles. That is, the consumer has convex preferences. Now, students should not get confused between convex IC and convex preference. Guys, the two are different concepts. Convex ICs means diminishing marginal rate of substitution. Convex preferences means averages are preferred over extremes. If I draw a diagram, So in the diagram, you can see on your screens, this is good X on the horizontal axis and good Y on the vertical axis. You can see I have taken 2 points. This is point A, which is x1 comma y1. Okay, this point is x1 and this point is y1. And guys, I take another point. Suppose this is point B. Okay, point B corresponds to x2 comma y2. This point is x2 and this point is y2. And suppose points A and B are lying on the same indifference curve. Suppose points A and B are lying on the same indifference curve. Now, guys, if I take the average of these 2 points, how will I take the average? So if I join points A and B with a straight line, where will the average lie? I hope students know how to find the average. Average will be the bundle C, which is nothing but x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So this will be my average bundle C, which will be x1 plus x2 by 2, comma y1 plus y2 by 2. You can clearly see, guys, that my bundle C is lying on a higher indifference curve. If you look at bundle C, it lies on a higher indifference curve IC1. So you can clearly see that the average bundle is preferred by the consumer over the extreme bundles A and B. So if we write the explanation clearly from the above diagram, the average bundle C, which corresponds to x1 plus x2 by 2, comma y1 plus y2 by 2, is strictly preferred over bundle A, which corresponds to x1 comma y1, and it is strictly preferred over bundle B also, which corresponds to the bundle x2 comma y2. So this is the fifth property, and this simply means that the consumer has convex preferences. Again repeating, please do not confuse. I am writing it. Please do not confuse convex preferences. Please do not confuse convex preferences with convex ICs. The two are different, guys. The two concepts are completely different. Convex ICs means that the slope of the indifference curve, which is MRS, is diminishing. But convex preferences means that my average bundle, which is bundle C, is preferred over the extreme bundle, which is bundle A and B. So guys, this is where I intend to stop. We have done with the properties of indifference curves. Now in the next lecture of consumer theory, we will look at two extreme cases of indifference curves. This was the general case which we had done, but we'll look at two extreme cases which violate some of the properties of indifference curves, which I will be covering up in the next lecture of consumer theory. Okay, so I hope all students have enjoyed this lecture. Any doubt, you can unmute your mics and ask, or you can call up or mail me your doubts at divineschoolofeconomics@gmail.com. In the next lecture, we will continue with the lecture on consumer theory. So this is where I stop.